Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to teach about plastic. See, in this I am going to cover these topics. The first one is plastic. What is the definition of plastics? And second one is advantages of plastic. What are the advantages we have with plastics? And classification of plastics. What are the classifications are there in the plastics? And the thermoplastics and thermosetting plastics and difference between thermoplastics and thermosetting plastics we are going to learn in this video. In this video, I am going to teach about plastics. What is the definition of plastic and advantages? What are the advantages present in the plastics and classification of plastics? Those are thermosetting plastics and thermoplastics and differences between thermoplastics and thermosetting plastics. See, first we are going to learn about introduction to plastics. What is the introduction of plastics? See, the word plastic derived from Greek, in which plastic means moldable. The word plastic, it belongs to the Greek word. The Greek word, the plastic means moldable. We can convert one shape to other shape with easy conversion. That is called moldable. The word plastic derived from the Greek word. In Greek, the plastic means moldable. These are high molecular weight organic materials. The plastics are high molecular weight organic materials. In the plastic means, in Greek word, the plastic means moldable, and these are high molecular weight of organic materials. High molecular weight of organic materials called plastics. Plastics are made by polymers and additives. The plastics are made by polymers and additives. We can synthesize plastics from the polymers and adding by some additives to the polymers. Then we can prepare the plastics. The plastics can be synthesized by using polymers and additives. Polymers which can be molded into hard, tough and utility articles by the application of heat and pressure are called plastics. Polymers which can be molded into hard and tough. The polymers can be molded into hard and tough, and you can prepare utility articles by the application of heat and pressure are called plastics. What are the plastics? Polymers which can be molded into hard and tough and utility articles. We can synthesize or we can prepare utility articles by using application of heat and pressure to the polymers. Then we can prepare the plastics. Polymers may be natural or synthetic, but plastics are synthetic only. Already we discussed polymers are natural polymers are there, artificial polymers are there, but polymers are maybe natural or synthetic. Polymers may be natural or synthetic, but plastics are synthetic only. The plastics can be synthesized from the polymers only. So the polymers may be artificial or natural, but plastics are synthetic only. There is no natural plastics are exist. Okay. All plastics are polymers, but all polymers are not plastics. All plastics are polymers. All plastics are polymers, but all polymers are not plastics. The plastics are synthesized from polymers only. So that's why all plastics are polymers. All plastics are polymers. The plastics are derived from the polymers only. But all polymers are not plastics. All polymers are not plastics. Example: polyethylene, polystyrene, nylon, polyesters, etc. The example for plastics are polyethylene, polystyrene, nylon and polyesters. These are the example for the plastics. See, the plastics, advantages of plastics in engineering materials. Advantages of plastics in engineering materials. See, the first one is the low fabrication cost. The plastics having low fabrication cost. The preparation cost is very less for the plastic. And it contains low thermal and electrical conductivities. The plastics contain low thermal and electrical conductivities. It contains low thermal and low electrical conductivities. And high resistance to corrosion and solvents. The plastics are high resistance to the corrosion and solvents. Okay, the first one is the plastics having low fabrication cost and it contains low thermal and electrical conductivities and it contains high resistance to the corrosion and solvents. The second advantage of this plastic is the stress-strain relationship of plastic is similar to that of metals. The plastics contain the stress and strain relationship between the stress and strain relationship of plastics is similar to that of metals. Okay, it acts as the stress-strain relationship is similar to that of metals. So it exhibit properties like metals. The plastics exhibit properties like metals due to the stress and strain relationship of plastics are similar to that of metals. Okay. The third advantage of plastic is plastic reduce noise and vibration in machines. The plastic reduce noise and vibrations in machines. The plastic reduce noise and vibrations in machines. Okay. This is the third advantage of the plastic materials. The fourth application is plastics are bad conductors of heat are useful for making handles used for hot objects. Most plastics are inflammable. The plastics are bad conductors of heat. The plastics are bad conductors of heat. So we can make the handles of a hot object. We can make the by using this plastic we can prepare or we can make the handles for the hot objects uh, to hang. Okay. Most plastics are inflammable. The most plastics are inflammable. The most of the plastics are inflammable. Plastics are bad conductors of heat are useful for making handles. Used for hot objects. Okay, used for hot objects. Most plastics are inflammable. Most plastics are inflammable. Okay. The fifth advantage of plastics are the plastics are electrical insulators. The plastics are electrical insulators and find large scale use in the electrical industry. We can prepare large number of electrical articles by using these plastics. Okay, the plastics are electrical insulators. Find large scale use in the electrical industry. The sixth advantage of plastic is plastics are resistant to chemicals. The plastics are resistant to chemicals. The plastics are resistant to the chemicals. The seventh point is plastics are clear and transparent, so they can be given beautiful colors. The plastics are clear and transparent, so they can be given beautiful colors. Okay, these are the advantages. What are the advantages of the plastic in engineering materials? See, the first one is it contain low fabrication cost. Plastic contain low fabrication cost and low thermal and low electrical conductivities, and it shows high resistance to corrosion and solvents. The second advantage of plastic is the stress and strain relationship of plastic is similar to that of metals. The stress and strain relationship of plastic is similar to that of the metals. The third advantage of the plastic is plastic reduce noise and vibration in machines. The plastic reduce noise and vibration in machines. The fourth advantage of the plastic is plastics are bad conductors of heat. The plastics are bad conductors of heat are useful for making handles used for hot objects. And the plastics are bad conductors of heat are useful for making handles used for hot objects. Most plastics are inflammable. Most of the plastics are inflammable. Plastics are electrical insulators. Plastics are electrical insulators and find large scale use in the electrical industry. Find large scale use in the electrical industry. The plastics are resistant to chemicals. The plastics are resistant to chemicals. And the plastics are clear and transparent, so they can be given beautiful colors. Plastics are clear and transparent, so they can be given beautiful colors. Plastics are classified into two main types. Plastics are divided into or classified into two main types. One is thermoplastic and second one is thermosetting plastic. One is thermoplastic and thermosetting plastic. Plastics are classified into two types. One is thermoplastic and second one is thermosetting plastic. See, this is the definition for thermoplastic. This is the definition for thermoplastic. Thermoplastics can be softened on heating, hardened on cooling. What is the thermoplastic? Thermoplastics can be softened on heating. On heating, the thermoplastics are softened. On hardening, on cooling. On cooling, these will be hardened. Okay, that is thermoplastics can be softened on heating and hardened on cooling. They are generally soluble in organic solvents. The thermoplastics are generally soluble in organic solvents. Once cooled, if the thermoplastics are once cooled, they show no changes in chemical properties. They show no changes in chemical properties, meaning they can be remelted and reused several times. The thermoplastics are they can be remelted and reused several times. What is thermoplastics? Thermoplastics can be softened on heating. The thermoplastics are softened on heating, hardened on cooling. The thermoplastics can be softened on heating and hardened on cooling. They are generally soluble in organic solvents. The thermoplastics are generally soluble in organic solvents if once cooled. Once cooled, what happens? They show no changes in chemical properties. There are no changes in chemical properties of the thermoplastics if once cooled. If once cooled, they show no changes in chemical properties. The chemical properties are not changed on cooling. Okay, meaning they can be remelted and reused several times. By this property, we can say they can be remelted and reused several times. The thermoplastic can be reused or remelted several times. Example for thermoplastics are polyethylene and polyvinyl chloride. These are the example for thermoplastics. The thermoplastics are prepared by addition polymerization. How we can prepare thermoplastics? The thermoplastics are simply prepared by using addition polymerization. Okay, simple addition polymerization we can prepare the thermoplastics. See, for polyethylene and polyvinyl chloride, we have seen in the addition polymerization. By simple addition polymerization, we can synthesize the polyethylene and polyvinyl chloride. So the thermoplastics are example for the addition polymerization. They are straight chain or slightly branched polymers. The thermoplastics are straight chain or slightly branched polymers, and various chains are held together by weak van der Waals forces of attraction. See, they are straight chain or slightly branched. The thermoplastics are straight chain or slightly branched polymers, and various chain are held together by weak van der Waals of forces of attraction. See, this is the thermoplastic polymer. See, this is one chain and this one is one chain. These two chains are held together by weak van der Waals forces. These two chains are the two chains in the thermoplastics are held together by weak van der Waals forces. Okay, weak van der Waals forces between the two chains present in the thermoplastic. Okay, the weak van der Waals forces are exist between the two chains of the thermoplastic. Okay, thermosetting plastics are thermosets. Thermosetting plastics are thermosets. The thermosetting plastics gets hardened on heating. Once hardened, they cannot be softened again. The thermosetting plastics get hardened on heating. The thermosetting plastics get hardened on heating, and once hardened, they cannot be softened again. They cannot be softened again. The thermosetting plastics get hardened on heating, and once hardened, they cannot be softened again. They cannot be softened again. The thermosetting plastics are prepared by condensation polymerization. The thermosetting plastics are prepared by simple condensation polymerization. See, the thermoplastics are prepared by simple addition polymerization. Here, the thermosetting plastics are prepared by using simple condensation polymerization. Okay, the thermosetting plastics are prepared by simple condensation polymerization. Various polymer chains are held together by strong covalent bond called crosslinks. The various polymer chains are held together by strong covalent bond. See, the two chains are present in the thermosetting plastics are held together by strong covalent bond. In the thermoplastics, two chains in a thermoplastics are held together by weak van der Waals forces. But in case of thermosetting plastics, two chains in a thermosetting plastics are held together by strong covalent bond or cross links called cross links. Okay, they are almost insoluble in organic solvents. The thermosetting plastics are almost insoluble in organic solvents. The in addition polymerization, the addition polymers are thermoplastics are they can be soluble easily in organic solvents. But here the thermosetting plastics are are almost insoluble in organic solvents. Okay, the example for thermosetting plastics are bakelite and polyesters. Example for the thermosetting plastics are bakelite and polyesters. See, these are the differences between thermoplastic and thermosetting plastic. Here thermoplastic and here thermosetting plastic. See, the thermoplastics are usually formed by the addition polymerization. The thermoplastics are generally prepared by using simple addition polymerization. See, the thermosetting plastics are often formed by the condensation polymerization. The thermosetting plastics are often formed by the condensation polymerization. The thermoplastics are prepared by using addition polymerization, and thermosetting plastics are prepared by the condensation polymerization. It contains long chain and linear polymers and held together by weak van der Waals forces. In the thermoplastic, the two chains are long chains or linear polymers and held together by weak van der Waals forces. The weak van der Waals forces existed between the two chains in a thermoplastic. The weak van der Waals forces existed between two chains of thermoplastic, okay, thermoplastic polymer. See, in the thermosetting plastics, what happens? It contains 3D network structure. It contains 3D network structure constructed with strong covalent bonds. Here, in case of thermosetting plastic, there is a strong covalent interactions present between the two chains of a thermosetting plastic. But in thermoplastic, weak van der Waals forces are existed. Here, the strong covalent bonds are existed in case of thermosetting plastic. See, usually becomes soften on heating and stiffen on cooling. Thermoplastics are usually becomes soften on heating and soften on cooling. See, usually becomes soften on heating and stiffen on cooling. Thermoplastics. But thermosetting plastics are, it does not become soft on heating. It does not become soft on heating. Thermosetting plastic does not become soft on heating. The thermoplastics are expensive. The thermoplastics are expensive, but the thermosetting plastics are cheap. The thermosetting plastics are cheap. Okay. The thermoplastics is soluble in organic solvents. The thermoplastics are soluble in organic solvents. The thermosetting plastics are insoluble in organic solvent. The thermosetting plastics are insoluble in organic solvents. They are usually soft, weak, and less brittle in nature. The thermoplastics are usually soft, weak, and less brittle in nature. Less brittle in nature. But the thermosetting plastics are usually hard, strong, and more brittle in nature, because the thermoplastics are contain weak van der Waals forces. That's why these usually soft and weak and less brittle in nature. But there are covalent bonds are existed between thermoplastic. Okay, that's why they are usually hard and strong and more brittle in nature. The thermoplastics can be remolded. The thermoplastics can be remolded. But the thermosetting plastics, they cannot be remolded. The thermosetting plastics cannot be remolded. An example for thermoplastic is polyethylene. An example for thermoplastic is polyethylene. And the example for thermosetting plastic is bakelite. The example for thermoplastic is polyethylene. And the example for thermosetting plastic is bakelite. See, once again, what is the polymers? The plastics are classified into two types. One is thermoplastic and second one is thermosetting plastic. What is thermoplastic? The thermoplastic is nothing but it can be softened on heating, hardened on cooling. The thermosetting plastics are softened on heating and hardened on cooling. They generally soluble in organic solvent. Okay, the thermoplastics are generally soluble in organic solvents, and once cooled, they show no changes in chemical properties. Once if cool the thermoplastic, there is no changes in the chemical properties. Meaning they can be remelted and reused several times. The thermoplastics can be remelted and reused several times. Example for thermoplastics are polyethylene and polyvinyl chloride. The example for thermoplastics are polyethylene and polyvinyl chloride. Thermoplastics can be prepared by using simple addition polymerization. By using simple addition polymerization, you can prepare the thermoplastics. They are slightly chain or slightly branched polymers, and various chains are held together by weak van der Waals forces of attraction. In the thermoplastics, we can see the weak van der Waals forces of attraction between two chains of a thermoplastic. In a thermoplastic, in between two chains of a polymer, there is exist weak van der Waals forces in thermoplastic. See the definition for thermosetting plastic and thermoset. The thermosetting plastics get hardened on heating, and once hardened, they cannot be softened again. The thermosetting plastics get hardened on heating, and once hardened, they cannot be softened again. The thermosetting plastics are prepared by condensation polymerization. The thermosetting plastics are prepared by simple condensation polymerization. Various polymer chains are held together by strong covalent bonds. The various polymer chains are held together in the thermosetting plastics are strong covalent bonds. They are almost insoluble in organic solvent. The thermosetting plastics are insoluble in organic solvents. Example for the thermosetting plastics are bakelite and polyesters. See, these are the differences between thermoplastic and thermosetting plastics. The thermoplastics are usually formed by the simple addition polymerization. The thermosetting plastics are formed by the condensation polymerization. The thermoplastics contain weak van der Waals forces between two chains of a thermoplastic. In the thermoplastic, the between two chains there is exist weak van der Waals forces. But in case of thermosetting plastic, there are strong covalent bonds are existed between the two chains of thermosetting plastics. usually become soften on heating and stiffen on cooling. The thermoplastics are usually become soften on heating and stiffen on cooling. But in case of thermoplastic, it does not become soft on heating. It does not become soft on heating. The thermoplastics are less expensive, but the thermosetting plastics are cheap. The thermosetting plastics are cheap compared with the thermoplastics. The thermoplastics is soluble in organic solvents. The thermoplastics are soluble in organic solvents, but the thermostatic plastics are insoluble in organic solvents. They are usually soft, weak, and less brittle in nature. The thermoplastics are soft, weak, and less brittle in nature. But in case of thermosetting plastic, they are usually hard, strong, and more brittle in nature due to covalent bonds. These can be remolded. The thermoplastics can be remolded, and the thermosetting plastics cannot be remolded. An example for thermoplastic is polyethylene. An example for thermoplastic is polyethylene. And the example for thermosetting plastic is bakelite. The example for the thermosetting plastic is bakelite. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.